Hi everyone, this is Sushmita. Today we are going to learn the new topic. So it is a science session. So this chapter belongs to the 8th class Ncert science. If you want to take short note, then this video is for you. You can take screenshot. Otherwise, you can write the important things on your copy. So let's start the class. So the chapter name is Electricity, Magnetic and Heating Effects. That means the effect of electricity and magnet and their heating effects. Okay. What is electricity? Electricity is the flow of electric charge through a conductor. It is a form of energy that power our homes, schools or devices. So that means in the electricity, what happened? The electric charges are flowing through a conductor. Electric charges, that means the positive charge and negative charge, are moving in a conductor. So the examples are lightning, that is natural electricity, and batteries, that is chemical energy converted to electrical energy, power plants, generators producing electricity, solar planets, light energy converted to electricity. That means these are the example of electricity. Okay. So in this process, the positive and negative charge particles are moving from one place to another, and electricity working in different things. Okay. The next question is electric current and circuits. Electric current is the flow of charges through conductor. It is measured in amperes. Current flows from the positive terminal to the negative terminal of a battery through an external circuit. But the key components are battery, the source of energy, wires, path for current, bulb, load that uses the energy, switch, control the flow of current. A complete circuit allows uninterrupted flow of current. It is all about electric current and the circuits. Magnetic effects of electric current. When current flows through a wire, what happened? A magnetic field around it. You see a magnet, it has north pole and south pole. It has a specific area. In this area, iron particles are attracted. Okay, so those area are magnetic effect area. So those effects are called magnetic effects. Okay, so a compass needle placed near a current carrying wire deflects, providing the presence of magnetic field. This discovery was made Hans Christian Ørsted in 1820. The direction of magnetic field depends on the direction of the current. You can see the image of compass, that is, these are the poles, that is west, that is east, that is north and south, and it is the battery. It has the positive negative charge, wires. Okay. The next thing is, what is an electromagnet? A coil carrying wire A coil of wire carrying electric current produces a magnetic field around it. The more coils and stronger the current, the more powerful magnet becomes. The magnetic effect of an electromagnet can be turned on or off simply by switching the current or on or off. Unlike permanent magnets, this makes them useful for lifting iron nails and other metallic objects. A coil of wire carrying electric current produces a magnetic field around it. That means if we round more and more coils, then the current field is very strong. Okay. The magnetic effect of an electric magnet can be turned off by switching on, or can be turned off by switching the current. Okay. The next question is how to make an electromagnet. What is the process? So wrap insulated copper wire tightly around an iron nail. Make sure that coils are close together and cover most of the nail for a stronger magnetic field. Connect both ends of the copper wire. The terminals of a battery. Ensure the connections are firm so the electric current can flow through the wire. When the current flows through the coil, the iron nail becomes magnetized and acts as an electromagnet. It can now attract small iron objects like pins or nails. Okay. So what is the electromagnet? I draw the image. It is the iron nail. I can draw up the electric coil around it. Then it is a positive negative charge and we have to connect the battery here. Okay. So when we on the switch, current flows begin and it behave like an electromagnet. When we off the switch, then what happened? Electric flows are ruptured and it again become the electro. That is the it again became the iron nail. Okay. So it is a simple thing. You have to just take an iron nail and coil the electric wire, connect with a battery, and you have to switch on or off to see the electromagnet. How we know that it is working as an electromagnet? When we put here some iron pins, then what happens? When electric flow happens, these iron pins are attracted to each pole. But when we rupture the electric flow, the iron pins are not attracted. Okay. So it is all about the electromagnet. Applications of electromagnets, that is electric bells. Electromagnets are used in electric bells to create a rapid on-off motion that strikes the bell. Loudspeakers, that is electromagnets, work with permanent magnets to convert electric signals into sound vibration. In cranes, large electromagnets in cranes are used to lift, move heavy iron, steel objects and industries and scrap yards. MRI machines, hospitals used powerful electromagnets in MRI machines to produce detailed images of the human body. Heating effect of electric current. When current passes through a wire, it produces heat. This is known as heating effect of electric current. Electric bulbs glow because the filament heats up when current flows. Electric heaters use this effect to produce warmth. Fuse wires melt when excess current flows, protecting circuits from damage. So why heating effect of electric current? That means when electric current passes through a wire, it produces heat. This is known as heating effect of electric current. Why does heating occur? What is the reason behind it? Resistance convert electric energy into heat. When electric current flows through a wire, the wire resists the flow of electrons, causing them to collide and release energy as heat. Materials with higher resistance produce more heat. The amount of heat produced depends on three factors: the electric current, that is I, the resistance of the wire, that is R, and the time, that is T. For which current flows, that is heat proportional to current square into resistance into time. It is very important, that is heat, current and resistance. Okay, it is very important. Time. Okay. So four factors are very important, that is heat, that is current, that is resistance and time. More current or higher resistance means more heat generated. Examples of heating current, that is electric iron and electric stove. When current flows through the heating or coil, high resistance wire, electric energy converted into heat. The heat is used to press clothes in an iron or cook food or on an electric stove. Fuse wire, a fuse wire has high resistance and a low melting point. When excess current flows through fuse wire, heating off quickly and melts, breaking the circuit and protecting appliance from damage. Safety precautions. Avoid touching electric wires with bare hands. Always use insulated tools when working with electrical equipment. Do not overload sockets by plugging into too many devices at once, as this can cause overheating and fire hazards. Always switch off appliances when not in use to save energy and prevent accidents. Keep electrical devices away from water. Never attempt to repair electrical equipment without proper knowledge and adult supervision. So if you don't take the safety precaution, what happened? You injured yourself. So you have to avoid touching electric wires with bare hands. You have to wear the plastic slipper or you use wooden products. Okay. So it is better for you to use all these type of products. Simple experiment, that is magnetic effect. Materials needed, you can see the image here. It is a battery, it is a compass. Okay, materials needed, that is take a battery, copper wire and a magnetic compass. Place the compass on a flat surface and hold the wire close to it. Connect the wire ends to the battery to allow current to flow through the wire. What we observe? Okay, we can see the battery, we can see the compass. Here is the wire. What happened? When current flows through the wire, the compass needle deflects from its original position. This proves that electric current produces a magnetic field around the wire. Switch off the current and needle returns to normal. Similar thing we see before. Whenever electric flows, the magnetic compass have the magnetic power and compass deflected. Okay. Heating effect of experiment. Heating effect experiment. You can see the image here. Okay. Pass electric current through a thin resistance wire connected to a battery. Observe how the wire heats up as current flows through it. The wire may glow or become very warm, demonstrating the heating effect of the electric current. Question: always perform this experiment under teacher or adult supervision. Do not touch the wire while current is flowing. Disconnect the battery immediately after the observation. Summary or key points. Electric produces magnetic and heating effects. Electric Electromagnets work by passing current through coils of wire. The magnetic effect can be turned on or off by controlling the current. Heating effect depends on the resistance of the wire, the amount of current flowing through it. Safety with electricity is very important. Always use insulated tools, avoid touching bare wires, and never overload sockets. Electromagnets are used in electric bells, loudspeakers, cranes, and MRI machines. Understanding these effects helps us use electricity wisely and safely in daily life. You have questions? What happens when electric current flows through a wire? Name one use of electromagnets in daily life. Why does a fuse wire melt when too much current flows? How can we stay safe while using electricity at home? So it's all about the magnetic and electric effect and their heating effects. So if you have any doubt, you can ask some questions in the comment section. Otherwise, or if you want to take short note, I said that before that you have to take screenshot or you have to write important things. So let's end this session. Thank you.